Hi friends, this is a lecture number 4 of theory of machine. In this lecture, we discuss about the chain and its type and its uses in the theory of machines. Basically, in the previous lecture, that is in lecture number 3, we discussed about the chain. What is the chain and simple definition and some specific terms regarding the chain. So, mm, before starting this lecture, make sure that you must watch the previous lecture, that is lecture number 3. So, first of all, revise the previous term, that is the chain. What is the chain? In the definition of chain, we said that it is a specific arrangement and assemblance of the kinematic pair. And in this assemblance, the first link is attached with the last link end to end. Let's suppose that there is a link number 1, this is a link number 2, and this is a link number 3. In this assemblance there is 3 link, and first link end is attached with the last link of that is link number 3, so it make a chain. Okay, so it is clear what is the chain, but this chain may be in the motions and maybe statics. So on the basis of motions, we classify the chain into categories. That is, first one is a kinematic chain and second one is a lock chain. The kinematic chain is said to be those type of chain in which the motion is constant. That is, they have a motion, but the motion is a constant. And the second one is lock chain, which is it is those type of chain in which the motion is not constant. Okay, let's try to visualize it with the help of some example. Let's suppose that there is a two figure number 1 and figure number 2. Figure number 2, you are familiar with this figure because I generally use this figure more and more times. So it is a mechanism of the reciprocating steam engine. Okay, what is happening there? There is a link number 1, that is a piston along with the piston rod, and there is a link number 2 which is the crank, and link number 3 that is a crankshaft. Sorry, link number 2 is a connecting nut, and link number 3 is a crankshaft, and link number 4 is a frame. Here what you visualize there, you can visualize that first link end is attached with the last link, that is link number 4. So it form a chain. Okay, it form a chain. Apart from making the chain, it is also in the motion. It transfer the reciprocating motion in the rotational motion. So here is some transfer of motion, and this motion is a constant. Because why this is a constant? Because here the reciprocating motion is transferred only in the rotational motion. It is not depend upon the direction of forces. If we apply the forces by with some axle apart from the axis, it also then the crank rotate in the crank rotate. If we apply the axial force, then after that the crank is rotate. There is no dependence of the motions and the direction of the forces. So we can say that there is a motion is a constant. Here the motion is a constant. Now visualize the figure number 1. In the figure number 1, there is a 3 link. That is link number 1, link number 2, link number 3. The link number 2 may rotate along the link number 1. That is, here the link number 1 and here the link number 2. This link number 2 may rotate on the link number 1. That is, it may turn along the link number 1, and it also go forward and backward. So the link number 2 have a two type motion on the link number 1, that is the oscillation motion and the rotational motion. And here also the link number 3 have a rotational motion as well as oscillating motion. But the point that is the joint of link number 2 and 3 have only the reciprocating motion, that is the oscillatory motion. Here we can observe that the motion is not constant. The motion may be in any direction depending upon the situation. If this link is attached with another link, suppose that this is the link number 1, this is the link number 2, and this is the link number 3. If I apply force like in this direction, then it rotate on the link number 1. If I apply the forces axially, then it may slide on the link number 1. So what is happening there? The motion is not constant because it depends upon the direction of the forces. So we can say that it is a not constant motion. So let's check that it is a chain or not. Here the link number 2 and link number 3 and link number 2 and link number 3. The end of here the end. This is the end of link number 1. The end of link number 1 is attached with the end of link number 3. The link number 1 is the first link and link number 3 is the last link. So the end of first link and the end of last link is attached together. So we can say that this this arrangement make a chain, and it is a chain having no constant motion. Okay, chain having no constant motion. And here the figure number 2 have a constant motion and it make a chain. So we can say that it is a kinematic chain, that is a KC, and it is a LC, that means locked chain. Okay, I think you are able to understand what is the kinematic chain and what is the locked chain. But there is a question, why we have to study about the locked chain and the kinematic chain. Suppose you are going to understand the working principle and the mechanism of the any machine. So to understand the mechanism, you have to understand the motions and the arrangement at the same time. So if you want to understand the motions and arrangement, then you have to go through the chain. And if you have go through the chain, that is a must compulsory to understand it is a motion, it have a motion or not. So you can say that you can understand how it is important for us. Okay, now let's move on the another topic, that is how you can visualize any chain. It is a kinematic chain or it is a log chain. How you can understand it is a kinematic and it is a log? There are two ways to analyze any chain. First way is by visualizing and by understanding the mechanism of the arrangement of the chain. And second one is the by mathematical way. By mathematical way, how can understand it is a kinematic chain or log chain? We will discuss further. So here we are already discussed how we can analyze the chain by the visualizing the mechanism. So now I think we have to move to the topic that how can analyze with the help of the mathematics. There is a scientist whose name is A.W. Short form is A.W. Kelly. He make a different type of experiment on the different type of the kinematic chain arrangement. Why we call the different type of kinematic chain arrangement? Because the kinematic chain may have two types. First is a lower pair and the higher pair, depending upon the surface contact, which we will discuss in the previous lecture. So depending upon the kinematic pair, type of kinematic pair, they perform a various type of experiment with the chain, and they found that the relation between the number of kinematic pair, and the number of joint for the different type of the kinematic pair. For the lower pair, he found that the relation between the link and the kinematic pair is n is equal to 2p minus 4, and the relation between the joint and link is j is equal to 3 by 2 l minus 4, where L is known as the number of link, P is known as the number of kinematic pair, J is the number of binary joint. This is applicable only for a lower pair. For the lower pair, they found this two observation and this two fundamental formula for the kinematic chain. If any chain have this satisfied this formula, then this arrangement of chain is known as the kinematic chain. If it is not satisfied this formula at the same simultaneously, it must satisfy the both formula at a time. So if it satisfied both formula at a time, then we can say that it is a kinematic chain. If any arrangement cannot satisfy any of this equation at the same time, then we can say it is not a kinematic chain, it is a locked chain. So let's try to verify this formula for the lower pair. Here it is lower pair kinematic chain. Why we consider lower pair kinematic chain? Because the surface contact between the piston and this frame is so enough. So we consider the surface contact is large, so it is a lower pair. Now let's try to understand how much there is a, how there is a 4 number of link, because it is a link number 1 piston and piston rod is a link number 1 piston rod and crosshead is a link number 1, crank is a link number 3, connecting nuts is a link number 2, and the frame is a link number 4. So there is a 4 number of link, and the number of joint. The number of joint is 1, 2. It is not a joint; it is act as a at the same element. So the number of joint is 1, 2, and there is a 3, and there is a 4. 4 joint. The number of joint is 4. Now let's try revise how this is a 4 number. It is a 1 link. The piston rod and crosshead is a 1 link. So I take it is a 1. The connecting rod is 1 link, so it is a link number 2. The crank is a 1 link. Let's suppose this is a crank having link number 3. The frame has link number 4. The frame is a link number 4. So it is link number 4. And the first and last link is attached. The first and last link is attached end to end. So I attach the first and last link, that is link number 4, end to end. So it is here the joint. The number of joint is 1, 2, 3, and 4. Now I think you are clear about how there is a 4 joint. So there is a 4 joint. Now try to identifying the number of pair. This is a 1 pair. This is another pair. This is another pair. This is another pair. So total number of pair is kinematic pair is also 4. Kinematic pair, that is P. Okay. Now put this value in equation number 1 and equation number 4. If you put this value in equation number 2 and equation number 1 and 2, you get LHS equal to RHS or both equation. So what is going there? This we consider it is a kinematic chain because it's satisfying the both equation, and we can analyze it with the help of animation and with the help of figure. This is a kinematic chain, and with the formula it's satisfied. So we consider this formula is correct, and our analyzing of this figure is also correct. So now try to prove the this figure number 1. It is a lock chain by using this one, equation number 1, equation number 1, and equation number 2. Here the number of link is 3. L is equal to 3, and the number of joint is 1, 2, and 3. Number of joint J is equal to 3, and P pair is equal to 1 pair, 2 pair, and 3 pair. Number of pair is also 3. So if I want to find the pair between pair J and P, and we put the value of 1 and 2, we put the J, P value in equation number 1 and 2, then we got LHS is greater than RHS. So we can say that it is not satisfying the equation number 1 and 2, hence it is not a kinematic chain, it is a lock chain. So I think you are able to understand how to verify the kinematic chain and the lock chain by using the mathematical relation. This mathematical relation is very important for us. Okay, now try to understand the formula mathematical relation for the higher pair. For the higher pair, the first equation is a remain same, but in the second equation we do some modification. Why we do some modification? Because in the second equation there is a J, that is a number of joint. The number of joint may be differ for the point connection. Suppose it is a point connection, so it may be taken some different type of joint, which we visualize in the next lecture how we can analyze the joint in a higher pair. Okay, now only we have to understand the formula. In this formula, what we are adding? We adding only h plus 2 in the left side. left side, and the formula number one is remains same for the higher pair. Okay, so there is no any figure to prove this, no any figure for the higher pair, so we put this formula and verify this formula in the next lecture. So now let's try to our next topic, that is uh, that is number of joint in a chain. This formula have one condition, that is the value of j, have the value of j, that is the joint. The joint have only two link connection. That here I say that number of binding joint, that is the value of joint is this formula is only applicable for those type of kinematic pair in which the number of the number of link attached at a joint is equal to 2. Here is a joint in which the link this is the link number 1 and link number 2. That is the two link are joined at this point. But sometime in the any any chain, the number of joint the number of link at a single joint may be different. It may be 3 and it may be 4, depending upon the situation. Let's try to visualize it. Let's suppose there is a in a figure number 5, it is a joint where 1 2 3 links are joined at a same point. Then at this instant this formula is not satisfying, it is not correct for the this type of arrangement. There is one limitation and one condition, that is this formula is applicable only for the binary joint, the arrangement of the chain in which only the binary joint are available. Okay, for this formula, for this case this formula is applicable. So we have a problem how to solve how to analyze the different type of a chain if there is a more number of link joint at the single joint. How can we prove? By mathematics, this is a kinematic chain and this is a locked chain. For this we have to understand the different type of joint. First joint is binary joint, type of joint available in a chain. In the chain there is a two link joint at a same point, and maybe three link joint at the same point, maybe four link, 1 2 3 4 4 link are joined at the same point. On the basis of this arrangement, this number of the number of link joined at a point, we classify the joint in some category, like binary joint, ternary joint, and quaternary joint. In a binary joint, two links are joined at a point, and in a ternary joint, 3 number of links are joined at a point, and in a quaternary joint, the 4 number of links are joined at a same point. As you can visualize it in a figure number 3 3 5 and 6. In the figure number 3, two links are joined at a at a first point. Here the 3 number of links are joined. Here the 4 number of links are joined. So it is a binary joint. This joint is known as a binary joint. This joint is known as a ternary joint, and this joint is known as quaternary joint. So I think you are able to understand what is the ternary joint, what is the binary joint, what is the quaternary joint. But we have a requirement of a binary joint to prove this is a kinematic chain or this is a locked joint by using this formula number 1 and 2. So we have to find out the relation between the ternary joint and binary joint, ternary and binary, and quaternary and binary. That is how much binary joint are required to replace the ternary joint, and how much binary number of joint is required to replace the quaternary joint. Let's suppose that there is a 3 links which are joined at the same point. Suppose that this is a 3 links which are joined at the same point, same point. So it is a joint. This is a joint. Okay, it is a joint. This point is known as a joint. So if I want to join the 2 links at a time, then how much joint is required? Let's suppose that we have joined in a pair. If I join this these two link at one time, then we have a requirement of one join. And if I join this two link, after that we have to requirement of we have a requirement of another link to make this joint as a ternary joint. So we have requirement of an extra joint to attach here. So there is a there is a two number of binary joint is required to attach this ternary joint at the same point. I think it is not clear to you. Let's suppose there is a three link number one, this is a link number two, and link number three. Okay, this is a three link, and I want to attach this three link. Okay, but we have we have to take two link at a time. We have to two link at a time because we have to make a binary joint. So what I am doing, first of all, I attach link number one and link number two. Okay, so we have a requirement of one ribbit to join it. Okay, I join this link number one and link number two by using one ribbit. So I put here, I using the one binary joint to add this, and this two, then this two link number one and link number two, this two link act as one link. We treat it as a one link. We can treat it as a one link. Let's suppose that this is the link number k, and we have to add the link number 3 with the link number k. So adding the link number k with link number 3, we have a requirement of an extra ribbit, that is a second ribbit. That is, we have a requirement of another ribbit. So total number of ribbit required to join this is 2. We have a requirement of 2 ribbit to join this. So we can say that in the ternary joint we have, or we can replace, the ternary joint can be replaced by 2 binary joint because we have a requirement of 2 ribbit. Okay, now similarly we can we can say that one ternary joint is equal to 2 binary joint. So now similarly we try to visualize the same thing for the quaternary joint. For the quaternary joint, there is a 4 link, that is link number 1, 2, 3 and 4. If I want to join this 4 link together, so what I make a pair of 1 and 2. So attaching the 1 and 2 together and 3 and 2 together, we have requirement of pair 1 ribbit. Here is also requirement of 1 ribbit. So we can say that to make the make a pair of 3 and 4, make a pair of 1 and 2 join together, we have a requirement of 2 ribbit. And after that, after the attaching this number, the link number 1 and 2, it can be treated as a one link, that is the link number k. And after attaching the link number 3 and 4, we can treat it as another link which is known as L. And we have a requirement of an extra ribbit to attach the link number k and link number L. So we have a requirement of an extra ribbit. So total number of requirement of ribbit to attach is 3. So we can say that a quaternary joint can be replaced with the 3 binary joint. So we are able to replace the quaternary joint. We are able to replace the ternary joint and quaternary joint by using the some number of binary joint. Okay, so what is the benefit to understanding the relation between the ternary binary and the quaternary binary? By finding this relation, we are able to show, and we are able to analyze the kinematic pair by using this formula. How we can use this formula? Suppose that there is an arrangement. There is a figure number 5. In a figure number 5, here is a ternary joint, here is a binary joint, here is a ternary joint. So let's suppose the names are A, B, C, D and E. A, B, C, D and E are the joint where the D act as a D and D and A act as a ternary joint and link joint E, B, C act as a binary joint. If someone say that how much is their binary joint, what is the value of J? For the value of j, state that how much there is a binary joint, how much number of binary joint are available in the assemble. So if I want to find the number of binary joint, we can say that j is equal to EBC. There is a 3 binary joint and 2 generic joint, and one ternary joint is replacing by the 2 binary joint. So 2 ternary joint are replaced by the 2 binary joint. So simply we get 2 into 2. So there is a 3 plus 4, that is a 7 binary joint are available in this arrangement. That is in the figure number 5, there is a 7 binary number. 7 binary joint are available. Similarly, we can find for the figure number 6. It is your homework, and you please try to find out the number of number of binary joint available in the figure number 6, and number of ternary joint and number of quaternary joint available in the figure number 6. And after the finding this value, try to find out the value of j, how much total number of binary joint are available by replacing the ternary joint with the binary and quaternary joint with the binary. Okay, as we do in the figure number 5. And after doing that, try to put the value of L, J and P in the equation number 1 and the equation number 2, and try to understand where this arrangement is a kinematic chain or the locked chain. So I think it is more enough information about the chain. And after the studying this lecture, and by knowing this lecture, we are able to understand the type of chain, and what is the definition of chain, and what is the role of chain in the machines, and how it are beneficial for us. Okay, thank you for watching. Have a nice day.